Eddie the magic monk. Eddie the magic monk. Eddie the magic monk. Eddie the magic monk.
Hey guys, it's Eddie the Magic Monk. Welcome to another integration using partial fractions tutorial. So today we want to look at how to integrate this fraction here. Okay, now this is going to be quite different to any of the ones we have done, and I'll explain why that is. So here we definitely have no idea how to integrate it. Okay, so using any of the formulas we've tried before, we'll never be able to integrate it. So if we try to, there's even no way for us to separate it. So if we want to separate it using the method that we used in our previous video, where we separate it into two fractions with the same denominator. So let's say we have x plus 2 here, x plus 2 here, and we try to make the first fraction x plus 2, okay, and then we think of what we would add to give us this original fraction. Okay, same as the last video. If you haven't watched it, have a look at that one. Then we think about, okay, what will this add to give you this? Okay, so let's try and figure that out. We have x cubed, doesn't have anything here, so we'd have to plus x cubed plus x squared, because there's nothing there, plus there's already an x, so if you plus negative 4x, you'll get negative 3x. And then if you got a plus 2 here, so if you plus 1, you'll get plus 3. So we'll end up with this, but that still won't let us split it, okay, because we got a x cubed here still. And so basically it's pointless. It's pointless doing this. So our last method in the last video, it's not going to work, okay? So the only way to do this is to do what we call long division. Can't even spell division right now. But long division means we basically divide a big number by a small number using by hand. So if you guys remember if you don't remember how to do it, I'll give you a numerical example. You probably learned this in grade 3 or something. Let's say you have 132 divided by 2. 132. So you go 2 times 6 is 12. And then you go 13 minus 12. And then you bring down what is the remaining. So you bring that down. So you got 12 here. And then you go 2 times 6 is 12. Okay, so then the answer is 0. So 132 divided by 2 equals 66. Okay, something like that. Now, if you have another long division where you can't fully divide it by a number and get a whole and get a remainder 0. So for example, let's go 141 divided by 2. So you would get 2 times 7 is 14. And then you have a 1. And then you go 2 times 0 is 2 times 0 is a 0. So you have a 1 is remainder. Okay, so remainder 1. So when you write this as a equation as an answer, you write 141 divided by 2 equals 70 plus, and then you write the remainder divided by the divisor, 70 plus 1 over 2. Okay, so which is right, because 70 plus a half, which is 0.5, so that's 70.5. So that's how you do it. Okay, so now let's try to do it using this long thing. So you got x cubed plus x squared minus 3x plus 3 divided by x plus 2. Okay? Long division. Let's get rid of this to give us a bit more space. All right, how will we do long division here? Okay, so firstly, let's try and fit it by putting x plus 2, x times what will give you x cubed. X times x squared will give you x cubed, wouldn't it? So you go x times x squared is x cubed. X times x squared is x cubed. Okay, so that's good. But what about the 2? Well, you also have to multiply the 2 by x squared. So you go right plus 2x squared. You got to write it like that. Okay, and then remember that you do the minus. So you go minus. Okay, so then you keep going. Okay, so then you have x squared is over here minus, so let's go. X cubed minus x cubed is 0. Okay, you probably don't have to write 0. There's no point in doing that. X squared minus 2x squared. Okay, so 1 minus 2. 1 minus 2 is negative 1. Negative 1x squared. All right, 1 minus 2 is negative 1. Very simple. So then you copy down the next line. So minus 3x. So you go x times what will give you negative x squared. X times negative x. X times negative x will give you negative x squared, doesn't it? So you put negative x squared or negative 1x squared, same thing. X times x is negative x squared. Sorry, x times negative x. And then you go 2 times negative x is negative 2x. Okay, so you keep going with that. So then you go, okay, make sure you do the minus sign. So you have negative 1 minus minus 1. Negative 1 minus minus 1 is negative 1 plus 1. Negative 1 minus minus 1 is negative 1 plus 1, which is 0. So you got 0x squared, so you don't have to write it. Then you have negative 3 minus negative 2. So you got negative 3 minus negative 2 is negative 3 plus 2 is negative 1. So you have negative 1x. Then you have a plus 3 here. Okay, so then I think, okay, x times what will give you negative 1x. So x times negative 1 will give you negative 1x. So x times negative 1 is negative 1x. 2 times negative 1 is negative 2. Then you have to minus. So you go negative 1 minus minus 1 is negative 1 plus 1, which is 0. So you got 0x. 3 minus 2. Sorry, 3 minus minus 2 is 3 plus 2, which is 5. Okay, so rewriting this using this number numerical example, remember we said 142 divided by 2 is 70 plus 1 over 2. So we're going to do the same thing here. X cubed plus x squared minus 3x plus 3 divided by x plus 2 equals, and we're going to copy down this at the top, right, just like we did over here. So we have x squared minus x minus 1 plus, and we have over here we had 1 over 2. So over here we're going to put 5 over x plus 2. So we're going to use long division to separate. Okay, so once we use long division, okay, we can replace this with that result. Okay, so now we have been able to split up this huge fraction into this. X squared minus x minus 1 plus 5 over x plus 2. We've been able to split it. Okay, and that makes it so much easier to integrate because we can now just use our formula. We've got x squared integrates into x3 over x to the power of 3 over 3. Integrates into x squared over 2. Minus 1 integrates into x. And the last one integrates into ln x plus 2 times 5 plus c. Done. So that's when you have to use long division to separate the fraction. Thanks for watching.